Okay, and derivatives. Let's start. So let's start with one derivative. We know that that's 1 over 2 plus x. And right away, I'm going to rewrite this as 2 plus x to the negative 1 power. Now let's take another derivative. Second derivative, I'll bring the negative 1 down. 2 plus x to the negative 2 power. And derivative of the inside's 1, so it's all good. Third derivative, multiply these, so I get a positive 2 plus x to the negative 3. One more. Usually 4 does it. So I'd get a negative 3 times a 2 plus x to the negative 4 power. Okay. So we have, I think, 4 different things going on here. One of the things we've got going on is we've got 2 plus x to a power. Another thing we've got going on is we've got its alternating signs, right? Because it's going negative, positive, or positive, negative, right? And alternating signs. And the third thing is I've got numbers growing. Some numbers growing in the front, like here, right? These things. So let's tackle one at a time. So I'm going to make up the nth derivative. So I want to be able to, it's usually useful to look at like this, n equal 4. So when I'm on the fourth derivative, and I'm looking at this here, do you see that this is just negative n? Fourth derivative, negative n. Third derivative, negative 3. Two derivative, negative 2. There we go. So we got that one taken care of. Let's go to the next one with the numbers growing. So here I have 3 times 2. You probably know that that's 3 factorial. So if I'm on the fourth derivative, I'm on 3 factorial. If I'm on the third derivative, I'm on 2 factorial. So can you see that means n minus 1 factorial? And then for the alternating signs, I'm just going to tell you what to do. Try negative 1 to the n. So let's do it. So I'm just going to put in negative 1 to the n, and I'm going to see if it works. So when I'm plugging in n equal 4, negative 1 to the fourth, does it give me a negative number? Nope. Oh, okay. So that one doesn't work. Then this one will. So all you have to do is add a 1. So now if I plug in 4, I get negative 1 to the 5th power. That's negative. If I plug in 3, negative 1 to the 4th power. That's positive. There it is. A little tricky, but once you break it up into pieces, it's not so bad. Okay, so let's talk about the differential dy. So it's just a definition you need to know. So dy is equal to f prime of x dx. So the derivative, you know, is, by using chain rule, 2 secant of x times the derivative of secant, which is secant of x tangent of x dx. Now let's go plug in what we've got. So the dx is pi over 90. Just carry that along. And I'm going to put x is pi over 4 in all of these. So I have 2, and I know the secant of pi over 4. I'm just going to write it as secant of pi over 4 squared, tangent of pi over 4, and dy equals secant squared of pi over 4 is something you're just going to want to have memorized. It's 2. Let me just write it down here. Secant squared of pi over 4 is 2. It comes up so often. So this is, secant squared. So 2 times 2. Tangent of pi over 4, you know, is 1. And then times pi over 90. So this gives us 4 pi over 90. And that's a fine answer. Okay, so this sketching and finding dy. So let's see, we have, these two problems are from section 10. So dy, again, is the derivative dx. So if I take the derivative, I get 1/3 x to the negative 2/3 dx. So I plug in x equal 1 here, and dx is 0.04. Okay, there we go. That's the number that it is. So what does it look like? Okay, so first let's draw the function. X to the 1/3 looks like that. So I'm going to put x equal 1 here, and I'm going to make it really exaggerated. So here's 1.04. So we draw the tangent line at 1. And then the dy is the change in the y values on the tangent line. So between here and here. So this height distance right there is dy.